Hey guys, welcome to 5.4 Logarithmic Functions. In this lesson, we're going to be studying the derivative of logarithmic functions. So let's go ahead and just do a quick refresher of how we solve logarithmic equations. Now, let's take a look at letter A. Letter A, we said that ln is the same thing as log base e of 2x minus 3 is equal to 5. Now, if we want to solve this logarithmic the equation, we can use Scorpion to help us solve, and that is e to the 5 is equal to 2x minus 3. Add 3 to both sides. E to the 5 plus 3 is equal to 2x. Divide both sides by 2. Then we have all over 2, and you can use a calculator to find an approximation. Okay, now some properties of logarithmics are very important in calculus. It helps it make it easier to differentiate logarithmic functions. So before we talk about the differentiation of logs, let's talk about the logarithmic properties. Log base, well, let's just say it's base 10. Log of m plus log of n is the same as log of n times n. So I think I said n twice. It's m and n. Okay, this is called the product rule of logs, or the product law property of logs, however you want to say that. It just says that anytime we have a product of logs, we can write it as a sum of the logs with the arguments separated from each other. Very similar to the quotient property. A log of m over a log of m minus the log of n is equal to the log of m over n. Okay, so it says anytime we have a quotient, it can be expressed as a difference of logs with the argument separated. How do you know which argument goes on top? Well, the negative argument always goes, the negative log will go in the bottom, always. Okay, last property, the power property of logs. Log base m to the n is the same as n log base m. Okay, the power becomes a constant, so the n goes to the bottom. It's kind of like the power rule, but you don't take it away. You don't take 1 away from n. You just simply leave it as a multiple. Okay, so let's use these properties. Let's go ahead and do letter A. So letter A says rewrite the following expressions. Well, it's going to be ln of 3x minus ln of cosine x. This follows the property for quotients. Letter B, I should have wrote it like this. Okay, so we'll fix that in our notes in class. Ln of x to the third minus ln of e to the x. Now, the powers become multiples. Ln e goes away, so my final answer is actually just 3 ln x minus x. And I'll let you guys do the second A, which should be C, and the second B, which should be D, on your own. Now, we're going to go ahead and skip the sketching part of this. So I'll let you guys do that as an exercise. Okay, I'll let you guys do that on your own. So I'm going to go ahead and drop it all the way down here. Okay, anytime you take the derivative, well, I'll just give you the answer for this example right above. The derivative of ln x is 1 over x, where x is greater than 0, because ln cannot be 0. The argument inside ln cannot be 0. Okay, now a lot of times this constraint gets left behind. Okay, just understand, you don't need to write where x is greater than 0, you just need to understand that ln cannot be negative, cannot be a negative number or 0, so that's why we use this constraint for our derivative. So if the ln of x is equal to 1 over x, then what is the ln of u? Well, the ln of u is 1 over u times the chain rule, which is the u prime, as some people like to always, well, not always, but some people like to just say, well, it's simply just the u prime over the u, and that is your derivative of ln u. Let's go ahead and try it here. Why? What is my u? U is my sine. U is equal to sine x, and I need to find the u prime so that I can fit it in my rule. Cosine x is this derivative of sine. So y prime is 1 over u times u prime, which is cosine over sine, which is cotangent. If this is a multiple choice question, they won't have this, they'll have this. Next one, we have x times ln x, so I must use the product rule. G prime is equal to the first times the derivative of the second plus the second times the derivative of the first, which is really just 1, x's go away, plus ln x. Okay, and then it says here below, sometimes it's way easier to rewrite the logarithmic expression using the properties of log, then taking the derivative. You'll see this example in two ways. So I'm going to split this in half. Let's do the easy way first. So let's use the advice given here. Rewrite the log. So I'm going to rewrite the log way over here. So we notice that it's being multiplied. Okay, so it's going to be 3x ln x cubed, which is the same thing as 3x 3 ln x, which is also 9x ln x. You see, now I have the product of 9x ln x. Okay, now I don't have to worry about doing the chain rule of x to the cube. So now when I take my derivative of 9x ln x, I have a product rule. First times the derivative of the second plus the second times the derivative of the first. X's go away. Plus 9 ln x, which, if it was a multiple choice question, 9 1 plus ln x. Now let's do this the longer way. So let's just say I'm taking the product rule already. So u is 3x, u prime is 3, ln x cubed is v, so that means v prime is 1 over x cubed times x squared, which is 1 over x. Using the product rule will give me y prime is equal to 3x times v prime plus, u v prime and then v u prime, which is 3. Cancel the x's. Y prime is equal to 3 plus ln x, 3 ln x cubed. Now, what do we do next? Well, what do we do next is that, oh, I messed up. So real quick, guys, I forgot to do the chain rule correctly. It's 3, so that means it's 3. There you go, 3, and then this becomes a 9. So here we go. Using the power property for logs, the 3 goes to the front, so it's 9 plus 9 ln x, which is the same thing as what we got here. I'll let you guys go ahead and see what I did wrong, but go ahead and just try to make the connections.